Okay, our next topic that we need to cover is radical equations. So we're going to be solving equations that involve those radicals, mostly square roots and cube roots, although we could talk about higher ones as well. So consider the following equation that involves a radical. Square root of x equals 3. Now we want to solve the equation. Remember, when you want to solve an equation, we want to be able to get x equal to a number. So we think to ourselves, what can I do to that square root of x to turn it into just x? Well, square root of x, remember, is x to the 1/2. So we think to ourselves, what could I do to that? I want to get x. I want to turn that square root of x into an x. In other words, I want an x to the first. So we think to ourselves, okay, is there anything I could do to that exponent 1/2 that I could turn it into a 1? And we say to ourselves, well, if we multiply the 1/2 by 2, 1/2 times 2 would give me 1. To multiply by 2, though, to multiply the exponent, then we'd have to be raising it to a power, because that's the time that we multiply the exponent. So in other words, we'd have to square it. So in other words, if you squared square root of x, that would be x to the 1/2 squared, and using our properties of exponents, power to a power, we multiply 1/2 times 2, and we get x to the first. And so that's exactly what we're going to do with our equation. Is we're going to square it to get a x, but it's an equation, so if we do it to one side, we have to do it to the other side. So in other words, we square both sides. Square root of x squared is going to be x. 3 squared would be 9. We get the answer x equals 9. Now, it's not going to be an issue in this particular equation, but the process of squaring can cause negative signs to vanish. And that can actually lead to you getting an answer to the equation once you've squared both sides that actually won't be a solution to the original equation. And that's because squaring removes negative signs. We'll see that in a few moments in a future example. So in other words, when we square both sides of our equation, we need to check our solutions to see if they actually do satisfy the equation. So in our case, we would take that answer of 9, plug it back into the original equation, and then simplify both sides and see that in fact, yes, square root of 9 is in fact equal to 3, and so we get our answer 3 equals 3, and so that solution works. But we will see some problems later on where we square both sides and we get answers that don't work. And so that's why we have to check our solutions anytime we're solving an equation that we square both sides.